Okay, let's talk about the last three problems here in 3.4 that I had in the homework. Hope you're enjoying my attempt to have some fall colors here. It's kind of boring, a little bit drab here, but maybe appropriate. All right, let's see what we can do here quickly. First, I want to talk briefly about the translations. I'll talk briefly about the direct truth tables, and I'll talk about the indirect truth tables. Okay, problem number 2 here. The problem says, I'll be the champion of the whole wide world only if I beat Stow or Didi. I went ahead and put the abbreviations here, but they're similar kinds of things. And the next one, anyway, a little bit different in the other. Only if translates as a horseshoe and you maintain the order. If there's if between two claims and you flip the order, if and only if is a triple bar. A few people still getting that wrong. All right, so the first premise is if C, then S or D in parentheses. Okay. All right, it's the compound verb that puts the S or D together. Premise 2, we have I'll beat Didi but not Stow, but translates as an and right here. And then we just maintain the same abbreviations. We get not C for the conclusion. All right, let's go ahead and continue with the translations here in number 3. I'll be the champion of the whole wide world if I beat, scratch that. I will be the champion of the whole wide world, or I will beat both Byrne and Dave. Okay, the both Byrne and Dave groups B and D together. B stands for I'll beat Byrne, D stands for I'll beat Dave here, C stands for the same as we had up here before. All right, then I have in the second sentence, I'll beat Byrne, but I will not beat Dave. So there we get our second premise here, column. Same conclusion as we had before. All right, and that's how that goes. Final translation. There's leprechaun on my shoulder. We let that be L, if and only if it's beautiful outside. And that's went with B for it's beautiful outside. That was the first premise. And then we had furthermore premise indicators. You want to keep in mind if I'm able to read sideways and it's not beautiful outside, bring out the not. Straight if then, we leave it like that. And then we had, and I am able to read sideways. Of course I am. That's R. And conclusion L, there's a leprechaun on my shoulder. Okay, so that's how we get the translations there. Set up our table with all the premises, however many there are. We have 2, 2, and 3 in these 3 problems. And the conclusion, we're looking if we can ever have all the premises true and the conclusion false. So, directly. What I did here first was to go to the conclusion, not C. It's a simple claim, just a flip side of 4 trues and 4 falses. So I could line that up. Conclusion's true in case or rows 5, 6, 7, and 8. So we can scratch that out. Then I went to premise 2. It's usually false. We need both parts of an and to be true. The only time it's true is when we have D true and S false. And of the remaining cases, that's right here. False, 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 and rows 1, 2, and 4, scratch that out. Then we know we're down to premise 1. If it's true in this case, we can show invalidity. If not, we won't be able to. But alas, we do have T horseshoe T, which is true. So in row 3 as the arrow is here, we have C true, S false, and D true, as I say. Shows the argument invalid directly. All right, in number 3, I went with B and not D for reasons mentioned before. It's usually false first. Only true, well, when we have B true and D false, as you might think, if you think about how these things work. Scratched out the remaining rows down to row 2 right here. And we were also at row 6. Then I went over to the conclusion. The conclusion was false in the second row, but it was true because C was false over here in the 6th row. That knocked this out right here. And then I went up to second row, did the calculation. As soon as C is true, this whole thing is true. We don't even have to know the truth value of B and D. And we get in row 2, premise 1 true, premise 2 true, conclusion false. So we know it's invalid. We've shown it's invalid, and that's where C is true, B is true, and D is false, as I say over there. All right, in the 4th case here, similar kinds of things. I actually think because of time constraints, I'm going to go on and show some indirect tables here quickly. Okay, so what I have here is if C, then S or D. Okay, excuse me here. Actually, I'm going to do a time check here. Okay, All right, we're okay. All right, that's our first premise. Then we have D and not S, and our conclusion not C. Now we go with forced options. We have forced options in all these cases to make all the premises true and the conclusion false. I'm going to start with the second premise here and write it true under the D. D's got to be true for the second premise to be true, and S has got to be false, knowing how and not work. Big true over here, saying now we got the second premise true. We're trying to get all the premises true and the conclusion false. Notice based on what I just did, we have an if-then here. The expression in parentheses, the consequent is true, so we know that's true straight up. And now we're trying to get the conclusion false. Just make C true. We haven't assigned it a truth value yet, so we can do it. Get all true premise and a false conclusion. Same answer as we had above. A little bit quicker. But if you're efficient with these tables and don't calculate the whole thing, direct truth tables can work pretty well also. Remember, for the exam, you can print out these tables with the PDF. So if you're doing direct truth tables, don't write them all out. Print out a couple copies of the PDF so you can do this thing efficiently and within the allotted time. Okay, indirectly, we have C or B and D, and we have B and not D. Very similar kind of structure to the last time. This time I'll go to the conclusion first. I have to make C true to make the conclusion false, or a big F over here showing the conclusion is false. If C is true, notice at this point that automatically makes the first premise true because it's an or claim. One part of it's true. It's all we need for it to be true. And so I get first premise true, conclusion false, and I can get this second premise to be true as long as it wasn't a contradiction. We'd be able to do it here. B true and D false gives me the second premise true. Both true premise, false conclusion, same answers we had before. All right, finally, we have L, if and only if B. Two ways to make that true. L and B can both be true, or L and B can both be false, so we do not want to begin there. Several ways to make an if-then true, but a simple claim, of course, there's only one way to make it true or false. So we begin, we need to make R true and L false, really both of those. Okay, I'm going to go ahead and insert both of those into our table. With R true, now our hands are tied. We can't have T horseshoe F. If we're trying to get this second premise true, we can have T horseshoe T. So we need to make B false. And once B is false, we enter that wherever else it appears, crucially here in the first premise. That forces us to make L false to sort of save the first premise and make it true. And we can consistently, and you got to make sure to be consistent with truth value assignments, get all the premises true and the conclusion false. And so that's how we do that indirectly.